You know, we often talk about the heart as the symbol of love and emotion, right? But behind all that, it's one of nature's most perfect engines. So today, we're going to pop the hood and take a look at how this incredible biological machine actually works.
Just stop and think about that number for a second. 100,000 beats every single day for your entire life. It pumps every last drop of your blood through your whole body every single minute. So what's the secret? What is the brilliant design that lets this engine run nonstop without ever taking a break?
Well, it's so much more than just a pump. It's really like a conductor. It sits right there in the center of it all, directing this flow of life-giving blood to every single corner of your body with this perfect, unwavering rhythm.
To really understand how this whole operation works, we've got to start with its architecture. Let's begin with the 4 crucial chambers that make up the very foundation of the heart. So here's the basic blueprint. The heart is divided into 4 separate rooms, or chambers. You've got 2 on the top called the atria, and 2 bigger ones on the bottom called the ventricles. And honestly, this simple 4-chamber design is the secret to its incredible efficiency.
The top 2 chambers, the atria, are basically the receiving rooms. The name atrium literally means entrance hall, which is just a perfect description, isn't it? The right atrium collects all the oxygen-poor blood coming back from the body, while the left atrium gets all the fresh, oxygen-rich blood coming in from the lungs.
And right below the atria, you've got the real powerhouses, the ventricles. The right ventricle has a pretty easy job. It just sends blood on a short trip over to the lungs. But the left ventricle, it has the massive job of pumping that blood out to your entire body. And if you look closely at the diagram, you can actually see how much thicker and more muscular the wall of that left ventricle is. It needs all that extra power to push blood from the top of your head to the tips of your toes.
Okay, so how does the heart keep all this blood from flowing backward? That's where the valves come in. This view from the top shows the 4 valves, and you can think of them like perfect one-way doors. They swing open to let blood pass through, and then they snap shut to stop any of it from flowing back. It's all about keeping things moving in one smooth forward direction.
All right, so now that we've got the structure down, let's actually follow the blood on its journey. And it's not just one single path, it's actually a continuous 2-loop circuit, with the heart sitting right in the middle, like a central station.
So the heart is basically juggling 2 circuits at the exact same time. First up is the pulmonary circuit. This is where the right side of the heart sends that oxygen-poor blood over to the lungs to get a refill. Then that fresh blood comes back to the heart, which immediately sends it out on the systemic circuit. That's when the left side pumps that oxygenated blood out to the entire rest of the body. It's a beautiful system.
You know, this brings us to a super common misconception. A lot of us learned in school that arteries carry oxygenated blood and veins carry deoxygenated blood. But the real definition is way simpler, and it's all about direction. Just remember this. Arteries carry blood away from the heart. Veins carry it back to the heart. That's it. And that's exactly why the pulmonary artery, which carries deoxygenated blood away from the heart to the lungs, is still called an artery.
Okay, so we've seen the plumbing, but what makes the pump actually pump? Well, the answer is this incredible built-in electrical system that generates the spark for every single heartbeat.
The whole thing kicks off right here in what's called the sinoatrial node, or just SA node for short. It's this tiny little cluster of special cells in the right atrium, and it acts as the heart's own natural pacemaker. It just spontaneously creates an electrical impulse that sets the rhythm and the rate for your entire heart.
So, from that SA node, the electrical signal follows a very precise path. First, it zips across the atria, making them contract and squeeze blood down into the ventricles. Then the signal hits the AV node, and something absolutely crucial happens. It pauses, just for a split second. This tiny delay is so important because it gives the ventricles enough time to fill up completely with blood. After that little pause, the signal shoots down to the bottom of the heart and then sweeps upwards through the ventricles, triggering this powerful coordinated squeeze from the bottom up.
And what's really cool is that we can actually watch this whole electrical journey from outside the body. You've probably heard of an electrocardiogram or an ECG. It's a tool that records these very electrical signals as they travel through the heart, and it gives us this perfect visual map of the spark of life.
Each little part of that ECG line tells a story. That first little bump, the P wave, that's the atria contracting. Then you get this big spike, the QRS complex. That's the powerful squeeze of the ventricles. And finally, that last little wave, the T wave, shows the ventricles electrically resetting themselves, just getting ready for the very next beat. It's the entire heartbeat, written out in the language of electricity.
So, we've got the structure, we have the blood flow, and we have the electrical spark. Now, let's put it all together and talk about the actual sound that all this activity makes, the rhythm of the beat itself.
It's one of the most familiar sounds in the entire world, right? Lub-dub, lub-dub. But what are we actually hearing? It's not the heart muscle contracting. No, it's the sound of those 4 one-way doors, the valves, snapping shut with perfect timing.
That first sound, the lub, is what you hear when the ventricles start to contract. It's the sound of the lower 2 valves, the tricuspid and mitral valves, slamming shut to stop blood from going back up into the atria. This whole squeezing phase is called systole.
And the second sound, the dub, is the sound of the upper 2 valves closing as the ventricles relax and get ready to refill with blood. This relaxing and refilling phase is known as diastole. So, lub-dub, squeeze, relax, systole, diastole. That right there is the rhythm of life.
So, we end up right back where we started, this incredible fist-sized engine, with its complex chambers, its precise valves, its very own electrical system. It's going to beat more than 2.5 billion times in an average lifetime. I mean, can you think of any other machine that is so perfectly designed? It's just a true marvel, working tirelessly from our very first moment to our very last.